In this video, we will find how many roots does this equation have as function of positive a. As a first step, we rewrite our equation by taking a logarithm of both parts of them. So we have this form. We use the features of logarithm and rewrite this equation as follows. We divide now both parts of this equation over x, and finally we get this form of original equation. We analyze this equation using graphical method, and first we introduce two functions. First of them represents a left-hand side, and the second right-hand side of our equation. Next, we will sketch the left-hand side of our equation. First, we take x equal 1 and calculate y. Y is equal ln 1 over 1. Natural logarithm of 1 is equal 0, so we have here 0. So 1 and 0 are coordinates of the point on the plot, and this is this plot. Then we analyze the behavior of this function in the range between 0 and 1. So we take a limit x approaching 0. So our function will approach some value, ln x approaches negative infinity, x approaches 0, so we have here negative infinity. It means that the plot behaves something like this, which is shown here. As a next step, we analyze behavior of our function at large x. But to do this, we take x approaching infinity. We have this limit here. Both numerator and denominator approaches infinity, and we can apply L'Hopital's rule to this limit. So replace this limit as a limit of derivatives of numerator and denominator. Derivative of x in the denominator is 1. Derivative of ln x is 1 over x. So we have here this limit. X approaches infinity, so we have here 0. It means that in the range of large x, somewhere here, our function behaves like this. We don't have an exact plot, but for our goal it's necessary to have a sketch. So between these two ranges, we can see that this function first will increase, then decrease, so there is somewhere a maximum. X coordinate of the maximum we denote xm, y coordinate as ym, and next we will calculate these two values. To find coordinate of the maximum, we will take into account that derivative of our function at this point is equal 0. So we will find this derivative using standard equation of calculus. Derivative of ln x equal 1 over x. Multiplying with x, we will have here 1. X prime is 1, so we have for derivative this answer. To be 0, we need to find the root of this equation, and here xm equal e. To find ym, we plug in this answer to the function. We get this expression. Ln e equal 1. So we have ym equal 1 over e, or approximately it is equal to this number. Here we have a more accurate plot of our function, which is done by computer software, along with the our function, we can plot right hand side of this equation. So y equal ln a, this is a horizontal line. We see that there are point of intersection of this line and the plot of our function. These points provide the roots of this equation, and we will analyze several ranges of ln a. First, we consider ln a less or equal to 0. So in this range, there are only one point of intersection. Let's look again. It means that there is only single root here. Along with this equation, we can write equation for a in this form. Then we analyze the value of ln a between ym and 0. We see here that the horizontal line intersects the plot of the function in 2 points, and this happens everywhere in this range. So we can conclude that equation here has 2 roots, and a here can be written in this form. Now we consider point ym. Horizontal line is a tangent to the curve of our function. There is only one point of intersection, so there is single root, and a here is equal e to power 1 over e. The last range we need to consider is the range when ln is greater than ym here. In this range, there is no any point of intersection, so the equation has no roots. So for a greater than this, equation which we consider has no roots. We can summarize everything what we found in this picture. So for a in this interval and a equal to this value, there is a single root. For a between 1 and e to 1 over e, there are 2 roots. And for a greater than this value, there are no roots. We can make a graphical presentation of this, which is here. The ranges of single root, 2 roots, and no roots you can easily identify from this picture. The problem is solved completely. If you like this video, you may want to click like icon, leave a comment, and subscribe for the channel.